Ever wonder what the most extreme object in the universe looks like? Imagine something so bright it outshines a trillion suns. Something so massive it defies our understanding of physics. And something so distant that the light we see from it began its journey over 10 billion years ago. Today, we're talking about a cosmic monster, a true giant of the early universe. This is the story of TUN 618. First off, what exactly is TUN 618? It's not a star, and it's not a galaxy, though it sits at the heart of one. TUN 618 is a quasar. The word quasar is short for quasi-stellar radio source, which basically means it looks like a star but emits powerful radio waves. But that description doesn't do it justice. A quasar is the brilliantly luminous, active core of a very distant galaxy, powered by a supermassive black hole that is actively feeding. Think of it like this: a normal supermassive black hole, like the one at the center of our Milky Way, Sagittarius asterisk, is relatively quiet. It's not consuming huge amounts of material. But a quasar's black hole is a completely different beast. It's a voracious eater. Gas, dust, and even entire stars are pulled into its immense gravitational field. As this material spirals inward, it doesn't just fall straight in. It forms a massive, swirling structure called an accretion disk. Imagine a cosmic whirlpool the size of a solar system. Inside this disk, particles are accelerated to incredible speeds, rubbing against each other and generating immense friction. This friction heats the material to millions of degrees, causing it to glow with an intensity that is almost unimaginable. This is what makes a quasar shine. In fact, the light from the accretion disk is so powerful that it can easily outshine all the hundreds of billions of stars in its own host galaxy combined. A quasar is essentially a beacon, visible across billions of light years, signaling the presence of a feeding supermassive black hole. And TUN 618 is the king of quasars. It's one of the most luminous objects ever detected in the universe. But its brightness is just one part of the story. The truly mind-bending part is what lies at its center. The supermassive black hole powering TUN 618 has an estimated mass of 66 billion times the mass of our Sun. Let me say that again, 66 billion solar masses. To put that into perspective, the black hole at the center of our galaxy is about 4 million solar masses. That means TUN 618's black hole is over 15,000 times more massive than our own. It's not just in a different league, it's playing a completely different sport. This isn't just a supermassive black hole, it's an ultramassive black hole. It's one of the largest black holes ever discovered. The sheer scale of this object is difficult to comprehend. The event horizon of a black hole, its point of no return, is called the Schwarzschild radius. For TUN 618, this radius is enormous. If you were to travel around its event horizon at the speed of light, it would take you several days to complete one trip. The shadow cast by this black hole would be large enough to swallow our entire solar system multiple times over. It is a gravitational behemoth, a true monster of the cosmos. So, how does something this massive get so bright? TUN 618 is shining at a level that is incredibly close to a theoretical limit known as the Eddington limit. This is the maximum brightness an object can achieve before the outward pressure from its own radiation becomes so strong that it starts to push away the very material it is trying to consume. Essentially, TUN 618 is feeding at the absolute maximum possible rate. It's in a precarious state of balance, teetering on the edge between voracious consumption and blowing itself apart. This extreme feeding frenzy is what generates its unbelievable luminosity, making it visible to us even from a distance of over 10 billion light-years. But TUN 618's power isn't just expressed through light. It's also what's known as a radial-out quasar. From the regions just outside its event horizon, it launches to colossal jets of plasma. These jets are formed by intense magnetic fields that grab superheated material from the inner edge of the accretion disk and accelerate it to nearly the speed of light, flinging it out into space. These jets are cosmic particle cannons of unimaginable power. They stretch for hundreds of thousands of light-years, far beyond the confines of its host galaxy, plowing through the intergalactic medium. These jets aren't just for show. They have a profound impact on their surroundings. They heat up vast clouds of gas, preventing them from cooling down and forming new stars. They can effectively sterilize a galaxy, shutting down star formation and reshaping its evolution. The energy released by TUN 618 is so immense that it influences not just its immediate vicinity, but the entire galactic ecosystem it resides in. It's a force of both creation and destruction on a cosmic scale. Now, let's talk about that incredible distance. When we look at TUN 618, we're not seeing it as it is today. Because it's over 10 billion light-years away, the light we observe has been traveling for over 10 billion years to reach us. We are seeing TUN 618 as it was when the universe was less than a third of its current age, a time when galaxies were just beginning to form and grow. And this is where TUN 618 presents a major puzzle for astronomers. According to our current models of how black holes grow, it should take a very, very long time to build up a mass of 66 billion suns. You need to gather an immense amount of gas and dust and feed it into the black hole. Our theories suggest that this process should take much longer than the 3 to 4 billion years the universe had been around when we see TUN 618 in its prime. So, how did it get so big, so fast? This is one of the biggest questions in modern astrophysics, and scientists are exploring several possibilities. One idea is that TUN 618 experienced a period of hyperaccretion, feeding on an uninterrupted, massive fire hose of cold gas from the cosmic web, allowing it to grow at an exceptional rate. Another possibility is that it didn't grow from a single seed black hole, but was instead formed from the merger of several already large black holes in a dense, early universe environment. A third, more tantalizing possibility is that our understanding of black hole growth is incomplete. Perhaps there are exotic physical processes at play in the early universe that allowed for much more rapid growth than our current models permit. TUN 618 isn't just an object, it's a clue that's forcing us to rethink the fundamental rules of cosmic evolution. Now for the question you might be asking, is TUN 618 a danger to us? The short answer is a definitive no. Its immense distance makes it completely harmless. It's a spectacle we can safely observe from billions of light-years away. But let's indulge in a little thought experiment. What if a quasar like TUN 618 were located inside our own Milky Way galaxy? The consequences would be apocalyptic. Its intense radiation would bombard any nearby planets, stripping away their atmospheres and sterilizing their surfaces. The high-energy particles from its jets would make vast regions of space uninhabitable. Life as we know it would stand no chance. Fortunately, the era of giant quasars is largely in the past. The universe is much quieter now. TUN 618 is a testament to the fact that the universe is far more violent, extreme, and uninspiring than we can often imagine. It's a ghost from a bygone era, a beacon from the cosmic dawn when giants roamed the universe. From our small, quiet corner of the Milky Way, we have managed to build telescopes powerful enough to see this monster across billions of light-years. It's a reminder of the incredible power of science and human curiosity. By studying objects like TUN 618, we are peering into a cosmic laboratory where the laws of physics are pushed to their absolute limits. It challenges our theories, expands our horizons, and deepens our appreciation for the scale and complexity of the cosmos. TUN 618 is more than just a data point. It's a window into the most extreme environments the universe has ever produced, showing us that reality is often far stranger and far more magnificent than fiction. Thanks for joining me on this journey to the edge of our understanding. If you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and hit that notification bell for more explorations of the universe's greatest mysteries.